Saturn is already one of the most distinctive planets to us, with its beautiful rings made of ice. But did you know it also holds the title of being the planet with the most amount of moons in our solar system? That's right. As of March 2025, Saturn holds the record of a whopping 274 moons, with Titan, Enceladus, and Tethys being among its most well-known. And to think that Earth only has one moon. Could you imagine what our sky would look like with 274 moons constantly orbiting the Earth? Like and subscribe for more cool space and sci-fi content. Will you be its next victim? 26,500 light-years away from us lies a monster that is 4 million times the mass of the Sun, where it consumes every celestial object around it like a cosmic-sized Snorlax. However, it isn't a giant movie monster. But you wouldn't want to get close to it, unless you want to be turned into spaghetti! That monster is the supermassive black hole known as Sagittarius A star, or SGRA star for short. This is a very blurry image of SGRA star taken by the Event Horizon Telescope. Now before you start panicking, relax. Us being approximately 155.8 quadrillion miles away puts us impossibly far away from its 15.5 million mile event horizon radius. Unless you have a really fast spaceship, like I have, there is no chance of you being consumed by SGRA star anytime soon. The chaos has been raging on for over 350 years. The iconic red spot of Jupiter is actually a massive apocalyptic storm, more terrible than any storm witnessed on Earth by several orders of magnitude. The red color is thought to be the result of absolutely brutal chemical reactions in Jupiter's unforgiving atmosphere. 10 to 25,000 miles in diameter, wind speeds tearing between 270 to 425 miles per hour, and reaching hundreds of miles into Jupiter's atmosphere means that this storm, if it suddenly appeared on Earth, would utterly obliterate our puny world and everyone in it. Luckily for Jupiter, the red spot has been shrinking and may be totally gone within a few decades. It's impossible to not love these little dudes. Tardigrades, also known as water bears or moss piglets, are our lovable, 8-legged microscopic friends who possess some extraordinary biology. Their ability to survive extreme environments comes from a process they undergo known as cryptobiosis. This process involves the near shutdown of their metabolism, halting at nearly 0.01% their regular metabolic rate. They remain in this dormant state until the conditions of their environment improves. Not only that, they are capable of surviving extreme temperatures between -457 degrees Fahrenheit and 302 degrees Fahrenheit. In 2007, tardigrades were sent into space on the Photon M3 mission and were exposed to the harsh conditions of space for 10 whole days. Many of them survived and even reproduced after returning to Earth. We aren't the only ones that love them, so do astrobiologists. The tardigrade is studied extensively for how life may survive on other planets, as well as potential developments to help protect astronauts from the radiation of space.
Oh please, no, please, please, give me another chance, please, please, Queen, just a crumb, please, please, just a sniff, Queen, please.
20 light-years from Earth lies the biggest SIMP in our galaxy. SIMP J0136 is a rogue planet discovered in 2016 that has 13 times the mass of Jupiter. Its magnetic field is incredibly strong, about 200 times more than Jupiter's. Too bad its field isn't magnetic enough to pull any lady planets, as being a rogue planet means it drifts through space isolated from any other planet or star. The auroras atop its top side truly crowns it as king of all SIMPs. These auroras are most likely the result of its powerful magnetic field. With a surface temperature of 1500 degrees Fahrenheit, you'd think it would be hot enough to attract some sort of attention from other planets. Unfortunately, Venus wants nothing to do with SIMP. Maybe Mars will buy SIMP his favorite game console if he's a good boy. Aliens could find it at any moment. In 1977, Carl Sagan and his team at NASA launched Voyager 1 and Voyager 2 into space to explore the outer solar system. On board both these spacecraft is the Golden Disk, humanity's compendium accessible to any that find it. It contains a bunch of info about humanity, such as the sounds of nature, like thunder and a bird's song, 55 greetings in different languages, languages, 27 pieces of music from various eras of history, such as Mozart, Beethoven, and my favorite, Johnny B. Good by Chuck Berry. 116 photos and diagrams, showcasing images such as human anatomy, our DNA structure, and daily life on Earth. There also are instructions included on how to create a record player, should anyone find the disc. The location of Earth is on these discs, so we can only hope that whoever, or whatever, discovers the discs, they are friendly. It could help shape the future of space exploration. The Moon is only 238,900 miles away from Earth, which is extremely close in the sphere of space travel. A lunar starport would set the stage for easier future space exploration thanks to the Moon's attributes. No atmosphere means there is no air resistance to slow down rocket launches. Lunar regolith, the gray surface rock of the Moon, contains useful resources for rocket fuel, such as hydrogen, oxygen, and other metals. No weather or plate tectonics offers a stable platform to build infrastructure such as fuel depots and factories. Launching from the Moon could potentially avoid the political and environmental impacts of Earth-based spaceports. Would you want to work on the lunar starport? Its origin is unknown. In 2017, the first interstellar object, an object originating outside of our solar system, was observed by the Pan-STARRS 1 telescope. This object is known as Oumuamua, a Hawaiian name meaning scout or messenger from afar. It is a cigar or pancake-shaped object that is thought to be an asteroid or comet, with an estimated size between 300 and 1,300 feet long. Its unusual shape is unlike anything we have seen before, leading to speculation that it could have been an alien probe, though that idea is not widely accepted. It may have come from the direction of the Lyra constellation, but its true origins remain unknown. Oumuamua was observed for 11 days before it continued on its cosmic journey. What would you like to see visit our solar system next? Why is there a face on Mars? In 1976, NASA's Viking 1 orbiter relayed a photo taken in the Cydonia region of planet Mars. What appears in the photo seems to be a human face, sparking all sorts of speculation. What created this anomaly? Was it aliens? Ancient humans? A mischievous prankster at NASA? No, none of that. Unfortunately, it is just a plain old rock formation. The camera tech of 1976 simply didn't catch all the details, leading to the eerie photo. Subsequent missions to Mars between 1998 and 2006 with better cameras revealed a more detailed picture, showing the face as a mere rock formation. Man, I was really hoping it was aliens this time. I guess we'll keep searching. What if we could harness all of the sun's energy? In 1960, physicist Freeman Dyson suggested that if a civilization becomes advanced enough, it would eventually harness the power of its system's star. You may have heard of a Dyson sphere before, but there are actually three main versions of the concept. The first is the Dyson sphere, a solid, high-tech shell encasing a star to capture solar energy. This may not be feasible due to collapsing under the star's gravity. Then there is the Dyson swarm. Millions of solar energy-absorbing satellites orbiting the star. These satellites would capture energy from the star and beam it back to Earth. Lastly, there's the Dyson bubble, another swarm-like concept where thousands of statites, objects hovering in a fixed orbit aided by solar sails, would collect solar energy. The creation of a Dyson sphere-like concept would push us into Type 2 civilization territory on the Kardashev scale, which I will explain in the next video. We aren't even in the first tier yet. In 1964, astrophysicist Nikolai Kardashev proposed a framework to classify civilizations based on their tech and energy consumption. The classic scale had only 3 tiers, but modern extensions have expanded that to number to 6. Type 0. This civilization relies on natural resources and hasn't yet mastered control of its planet's energy. This is where we are at currently. Type 1 harnesses all available energy on the planet. We are nearing Type 1 status. Type 2, capable of using all the energy of their home star. The creation of a Dyson sphere-like megastructure would put us into Type 2 status. The forerunners from Halo were a Type 2 civilization. Type 3 controls all energy on a galactic scale. The Galactic Empire from Star Wars is a good example of a Type 3 civilization. Type 4, very speculative. Type 4 civilizations are capable of using all available energy in the universe. And finally, Type 5. Even more speculative, Type 5 civilizations can manipulate energy across multiple universes. For some perspective, humanity is currently at 0.72 on the Kardashev scale. We are nearing Type 1 status, but we still have work to do on a technological and societal level before that is possible. I will make you an expert in space rocks. You know about comets, asteroids, and meteors, but do you know what makes them different? Let's find out. Comets are icy objects that orbit the sun and are made of ice, dust, and rocky material, like a dirty snowball. Comets usually come from the Kuiper belt or Oort cloud, far beyond planet Neptune. Their distinctive glowing tails form when they near the sun due to evaporation from the heat. Asteroids also orbit the sun, but are composed of rock and metal. They mostly come from the asteroid belt located between Mars and Jupiter. Their size can range from a few feet to hundreds of miles across. In a way, they resemble the moon with their dry, cratered surface. They lack the distinctive tails of comets and meteors. Meteors are small chunks of asteroids that find their way to Earth. Their fiery tails come from the combination of friction and compression of Earth's atmosphere on the meteor. Next time you wish upon a shooting star, you'll know it is actually a meteor burning up in the atmosphere. Now that I've armed you with this valuable knowledge, you can laugh in the face of anyone that accuses you of not knowing the difference between comets, asteroids, and meteors. Icy worlds loom in the outskirts of our solar system. The Kuiper belt, a vast donut-shaped region of icy bodies beyond the orbit of Neptune, is home to frozen worlds classified as Plutoids, dwarf planets that orbit the sun beyond planet Neptune. Pluto lies within the Kuiper belt. Stripped of its planet status in 2006, Pluto now resides in its own cosmic neighborhood of similar dwarf planets. Eris is a highly reflective world that is smaller than Pluto, but has more mass. Haumea is unique for both its strange shape and ring system. Makemake shows signs of geothermal activity, possibly harboring a subsurface ocean. Even more worlds are pending classification as dwarf planets such as Gonggong, Quaoar, Sedna, Orcus, and Salacia. There are possibly several hundreds of these worlds within the Kuiper belt, lingering just beyond Neptune, watching us, waiting for us. There is nothing but darkness for millions of light years. The Boötes void, also known as the Great Nothing, is a vast area of complete darkness 700 million light years away from Earth, with the Boötes void itself clocking in at 330 million light years in diameter. Compared to our galaxy at 100,000 light years, around 3,300 Milky Way galaxies could fit within its diameter. Yet, only about 60 galaxies have been found in the Boötes void. Why is it so empty? Did an eldritch monster devour all the stars in the area? Did an alien civilization burn the stars for fuel? No, probably not. You see, the universe is structured in a sort of cosmic web, where galaxies are arranged in a way that leaves voids of space in between. The Boötes void just happens to be one of these voids of the extra-large variety. That's cool and all, but it's more interesting to believe it was a cosmic-sized monster that feeds on galaxies. Ever wonder what the rings of Saturn actually are? Much like comets, planetary rings form from cosmic debris comprised of ice, rock, and dust. They tend to form around gas giants, such as Saturn and the other gas giants in our solar system. Due to their sheer gravitational force, anything that gets too close to their orbit gets shredded into stellar particles. Simply put, planetary rings are cosmic graveyards of pulverized moons and asteroids with a touch of frost. Why doesn't Earth have rings? Wouldn't that be cool to see? Unfortunately, Earth is just too small and too close to the Sun to support planetary rings. Any ice that could accumulate in orbit would melt. Any rocky material orbiting Earth has either become part of our moon or burned up in Earth's atmosphere. Maybe if the moon mysteriously explodes, we could see a thin ring of debris orbit Earth for a bit. Once you cross the event horizon, there is no return. Black holes have become the bogeyman of space. But what actually are they? Let's find out. Black holes are the final step in a star's life cycle. Once the star runs out of fuel, it can no longer support itself against gravity, causing it to collapse in on itself. Stars have to reach a certain mass to become a black hole, typically 3 times the mass of our sun. There are 2 parts that make up a black hole. Number 1, singularity, a point of infinite gravity where all the mass is concentrated. Laws of physics as we know it do not apply here. Number 2, event horizon. This is what most people think of when talking about black holes. The event horizon is a threshold that once passed, anything in it cannot return. Matter, light, and even information cannot escape. There are 4 types of black holes: stellar, supermassive, intermediate, and primordial. The only real difference between them are their sizes, each one bigger than the last. Supermassive black holes in particular are what you see at the center of galaxies. The fear centered around black holes is real, but as long as you stay out of the event horizon, you should be fine. Like and subscribe for more cool space facts.